Now let's go ahead and do all four steps for a problem. Our example is a school budget. So your local paper polls a random sample of 330 voters, finding 144 who say they will vote yes on the upcoming school budget, and they want you to construct a 95% confidence interval for the proportion of voters who will vote yes. So step one is state, which is the proportion, the parameter we're looking for is the 95% confidence interval for the parameter of the true proportion of all voters who will vote yes on the school budget. Do not be afraid to kind of just almost copy and paste from the question, as long as you've got the right part of the question. Second step is to plan. What method are we going to use and what conditions? So far, we're on the very first method of inference, and that is provided the conditions are satisfied, we're going to use the normal model to find a one sample z interval for p. So this is the bold part, that's your method. What are the conditions again? First one's a random condition. They told you that it's a random sample. So just write down, it is given that the sample of voters is random. So we're satisfied on that condition. 10% condition. Well, provided there are more than 3,300 eligible voters, 330 is less than 10% of the population of voters. So we can say, okay, it's satisfied provided that this is true. And then finally, the large counts condition. We have 144 who say they'll vote yes, so that's greater than or equal to 10. Notice I didn't have to go n times p. I could have calculated the proportion and then multiplied it by 330, but guess what I get? 144. A nice way to do failure when you know the sample size is just take this number and subtract it from your n. So 330 minus 144 is 186, and that's definitely greater than or equal to 10. So that's satisfied, giving us all three conditions are satisfied, so we can proceed and do the do part, which is the calculations. Now I'm pulling this from your math chart. This is the section that we're going to use. The mean proportion is just p, and then the sigma for p hat is this. Now again, I'm going to use the term standard error. So p hat from our sample is 144 over 330, or roughly 0.436. I'm going to take this just to rewrite it, and I like to use q, but you don't have to. You can do 1 minus p, that's fine. And so my standard error, when I substitute in my numbers, 0.436 and 0.564, I get about 0.027. Then my margin of error is my critical value times my standard error for that. Now, I've told you it's worth memorizing for a 95% confidence interval. Do you remember what it was? It's 1.96. So I'm going to take that 1.96, a number you're going to see a lot, and multiply it by 0.027. And that gives me 0.053. So my confidence interval is 0.436, this value right here, my statistic, plus or minus my margin of error. And then I can go ahead and calculate my low value and my high value. Finally, step 4 is conclude, and I'm going to need those numbers to make my conclusion. And I'm going to use the boilerplate. We are 95%, I don't have C now because I know the confidence level is 95, confident that the interval, and this is from that what I just calculated, captures P equals a true proportion of all voters who will vote yes on the school budget. And that is first example we've done from start to finish.